All right, welcome to another riveting section of Algebra 2 with Mr. White here. We're going to go over section 2.3, which is all about real life systems. So we're going to put some of these algebra skills to work with, wait for it, word problems. Word problems, oh my. Okay, we got this. Now, this is a classic type problem. This is one of those, sometimes there's coins in a jar and you know how much it adds up to, you know it's only dimes and nickels. You can actually figure out how many dimes, how many nickels are in there. So I'm going to show you how to do this classic type problem. So let's read this together. A fourth grade class contributed 1770 in dimes and quarters to the Red Cross. In all, there were 96 coins. Now again, dimes and quarters in this particular problem. Find the number of dimes and quarters that they contributed, because we can actually figure this out, believe it or not. Isn't this cool? Yes, it is. All right. So first of all, we're going to use the letter D and the letter Q for our number of dimes and quarters, and the easy one is that dimes and, oh, my pencil stopped working here. Dimes and, this is really frustrating, I'm so sorry. Dimes and quarters, there it is 96. There are a total of 96 coins in there. So we write D plus Q equals 96. Now the second equation that you need to get down on your paper is the tricky one, but it's just how you count money. How you count money. All right, a dime is worth 10 cents, so you would take the number of dimes and multiply by 10, and then you would using a calculator probably, you'd take the number 25 and you'd multiply by the number of quarters, and all of that adds up to 1770. However, we need to write it in cents because the left side is all in cents, so we can't write dollars on the other side. So we have to convert the right side to 1,770 cents. Does that make sense? Yeah, good one. All right. I'm glad you're watching and paying attention. Okay, now we have our system, and we can totally ignore the word problem now, and we can just solve this guy. Now I'm going to do a transformation, or you could even go to Desmos and graph these two lines. There's nothing that says you can't go use technology on this. I'm going to multiply the first by negative 10. All right, I'm doing elimination so that I can add these up. 15Q equals, and then I go to my handy dandy calculator off to the side here, 1770 minus 960 equals 810. And now I take 810 divided by 15, it equals, apparently there's 54 quarters in there. Isn't that cool? 54 quarters. Now, how many dimes? Well, remember there's 96 coins, so all I have to do is subtract from 96 and I get 42 dimes. Now, how could we check our work? Count the money. Count the money, that's right. So dimes would be 42 times 0.1. That's $4.20 in dimes. 54 quarters, wow, times 0.25, that's 1350. So we get 1770. Look at that, we did it right. What do you know? We know how to do things. All right, good for us. Let's move on to the next one. Let me get that out of the way. All right, this one's a little tricky. A candy store sells chocolate for $7 a pound and peanuts for $3 a pound, but they're going to mix it together, and they want to be able to sell it for $4 a pound using the same pricing. How many pounds of each should we mix then if we're going to make a 20-pound mixture? So actually this 20-pound number we're not going to use until the end. So a candy store sells $7 a pound, and it's $7 a pound for chocolate, so I'm going to put a C, plus $3 a pound for peanuts equals, we want that to equal $4. So we want the ratio, the percentage, actually think of it as a percentage. So the percentage of chocolate, percentage of peanuts, it all has to add up to 100, by the way. that needs to average out in a way to be 4. So then, remember, this has to add up to 100%. So I'm just going to use that as my other equation. See, that's where this one got a little tricky in my opinion. Okay, so now we're going to use elimination method again. I'm going to multiply the second by -3, and I'm kind of chicken scratching here to move this along. So 4c equals 1, c equals 1/4, or 25%. So that must mean the peanuts will be making up 75% of the weight. All right, now we use that 20. Now that we have the answer, we actually have that it's a 1-to-3 ratio actually. But 25% is chocolate, and then the 3 parts would be the peanuts, the 75%. So you take the number 20 and you multiply by 0.25, that's 5. And then you take the number 20 and you multiply by 0.75 and you get 15 pounds. Okay, so 5 pounds of chocolate and 15 pounds of peanuts. So there you go. That was a tricky one. This one's actually a little easier. Candy, boy, I don't know if you know it, but here it's close to lunch and I'm kind of hungry, so all these food problems are killing me. John went to the store to buy white chocolate and dark chocolate. All right, and at the store, it's 50 cents for the white chocolate and then $1 for the dark chocolate. If he bought 25 pieces, all right, so the total number of white plus the total number of dark is 25. And if it totaled $15, so that's like a how you count money thing again, how you add up how much you owe. We're going to have to do for our second equation. So our second equation is going to be how much for white chocolate? Isn't it 50 cents? How much for dark chocolate? 1 for each one. And apparently that added up to $15. All right, so there is our system ready to go. So I'm going to scoot this over now, give myself more room. This is just screaming out for elimination method because the D's are lined up and we've got 1 and 1. So all I need to do is change the signs on one of the equations and I get 0.5W equals 10. I multiply both sides by 2 to get rid of the 1/2 and I get W is 20. What does that mean again? The number of white chocolate pieces was 20. Now remember, they ordered 25 pieces, so dark chocolate must be 5. Now the way you could check your answer is by counting the cost on that, and lo and behold, it will really add up to $15. So there's another chocolate problem. Let's see if we got more food. Now this one's kind of tricky. You invested some money, but you invested it in 2 different ways. A stock fund that paid 10.5 and just a bond fund that paid 7. All right, so we're going to have our stock fund at 10.5%. So I'm going to change that to a decimal. And I'm going to use a big capital S for that. Plus, and then 0.07 on the bond fund. And we made $735 in interest. So when that calculation gets done, it's $735. Okay. Now, the other, we need one more equation. Well, remember, we invested $8,000. So S plus B total is $8,000. And then you would go ahead and solve this. Now, one way to solve this would be to go to Desmos and graph those 2 lines and figure out where they hit, and that'll be your S and your B. Okay? So let me go ahead and do this real fast for you. I'm going to, let's see, what method should I use here? I think I'm going to multiply by 100 first of all. 10.5S plus 7B equals, and then I have to add 2 zeros on the end of that. I took the first one and I moved all the decimals over twice. And then I'm going to take the second one and I'm going to multiply by -7. Oops. All right, so that wasn't too bad. Now I can add them together and I get 2.5s equals, and I have to subtract here, 17,500. Now I'm going to go to my handy dandy calculator. 17,500 divide by 2.5, and I got 43,750 was invested in the stock fund. And then remember, we only invested 8,000. So I'm going to minus, I think, was my decimal wrong? I must have typed that in wrong. Hang on one second. Unfortunately, there's a no redo button on the videos. Let me try this again. 17,500 divided by 2.5. I think I hit times. 7,000, there she is. 7,000 for stocks. That means 1,000 for bonds, because remember, they had to add up to 8,000. So that's how I knew I was wrong. I was way over 8,000. Okay, we have one more problem, and this is an interesting one. It's a train leaving the station problem. So they're both starting in the same place. You've got a northbound train that travels a certain distance, and then you have a southbound train that travels a certain distance. Two trains leave Tulsa, one going north, one going south, after a certain amount of time. Now, distance equals rate times time. Distance equals rate times time. We don't know the rate of the northbound time, but we do know that after 4 hours, so that's the time that we're going to be talking about in both of these. And I'm using the subscripts to keep track of north and south differences here. Okay? Now, after the 4 hours, they are 376 miles apart. So what that tells me is that 4RN plus 4RS, the total distance, they add up to be 376. Now you might wonder why I didn't use D sub N and D sub S. It's because we're not really solving for distance of each, we're solving for the speed of the train. So I didn't want to bring D into the mix, although we could. We need another equation. We need another clue. Do we have another clue? Let's go over here and look. If the northbound train is traveling 10 miles an hour faster, there it is. So the northbound train is 10 plus the southbound train. There's our system. See, it is a bit challenging to get the two equations on your paper. I will remind you that distance equals rate times time. So anytime you have a car traveling or a train traveling or a train traveling and there's distance and rates involved, write D equals RT on your paper, and that will help a lot. D equals RT, distance equals rate times time. All right, I'm going to go ahead and do the substitution method this time. Because I have that substitution, I can go ahead and plug this right in there because that's the same as R sub n. So here we go. I'm going to put that in, change my color, 10 plus R sub s. Now I'm going to do the distributive property, 40 plus 4RS plus 4RS equals 376. And we are home free, folks. We have 8RS. That means the rate of the southbound train, R sub S, fancy way. Look, this looks all fancy. If your parents saw you doing this, they'd go nuts, right? Really impressed. 336. So the rate of the southbound train, I got to go back to my calculator, 336 divided by 8. 42. 42. Sorry about the announcement right now. Now remember, the northbound train goes 10 miles an hour faster. So there's the answer. MPH. MPH. Again, sorry about the announcement going on over top of my voice. All right, that's all we got for these notes. This is not an easy section. All right, so the critical thing is to get the system on your paper and do your best to solve it then. You can always use Desmos, just graph the two lines and solve it. But all right, good luck. Let me know if you have any troubles.